All right, so the purpose of this section is we're going to be talking about the properties of logarithms. So there are 3 properties of logarithms that you want to make sure that you feel comfortable with. The very first property of a logarithm is the product property. So the formal definition states, let b, x, and y be positive real numbers where b does not equal 1. Then log base b of an argument where there is multiplication, so I'm taking x and multiplying it by y, is equal to log base b of x plus log base b of y. So the logarithm of a product equals the sum of the logarithms of the factors. So essentially what it's saying is when you have an argument that is being multiplied together, so you have 2 or 3 or how many ever items you have inside of that parentheses, you can separate all of those terms or all of those items up and you separate them through addition. But notice that each term is getting its own logarithm. So you started out with a single logarithm, log base b of x times y, and it equals 2 separate logarithms being added together, log base b of x plus log base b of y. I want to let you guys know that when you see this in homework or if you see this on a test, what's going to be asked of you is to take a single logarithm and to expand it, or to take an expanded logarithm and condense it. If you're condensing something, you're making it smaller. You're making it into a single logarithm. So this log base b of xy is the single logarithm. And when you're asked to expand the logarithm, that would be the log base b of x plus log base b of y. Okay. So your second property that we're going to look at is the quotient property. So there's some relationship between these two. So let b, x, and y be positive real numbers where b does not equal 1. Then log base b of x divided by y, so there is division in your argument, is equal to log base b of x minus log base b of y. So the logarithm of a quotient equals the difference of the logarithm of the numerator and the logarithm of the denominator. So again, if you're asked to write a single logarithm, then you would have log base b of the x divided by y. But if you are asked to expand your logarithm, you would have the log base b of x minus the log base b of y. Okay. Your third property is the power property of logarithms. Let b and x be positive real numbers where b does not equal 1. Let p be any real number, then log base b of x to the power p is equal to p times the log base b of x. So this property helps us take something that's in an exponent and to be able to bring it down. This is going to be super useful in sections 3.5 and 3.6 whenever we start to solve for variables that are in the exponent of a logarithm. This property allows us to take that exponent variable and bring it to the front. So the thing starts as an exponent, but when I utilize this property, it comes down as a regular number in front of the logarithm, and now it's multiplying your logarithm. Okay, so super, super useful. So you want to make sure you feel comfortable doing product, quotient, and power property, and we'll do some examples with these 3 properties in a second. Okay. All right, there are some additional properties of logarithms. So let b, x, and y be positive real numbers where b does not equal 1, and let p be a real number. Then the following properties of logarithms are true. So number 5, number 6, and number 7, we've already stated. Those are your product, your quotient, and your power property. But then we have numbers 1, 2, 3, and 4. 3 and 4 are not a big deal. We're not going to run into those often. But 1 and 2 go back to something I stated earlier, where if I know the base is b and the argument is 1, the answer has to be 0, because anything raised to the 0 power equals 1. And if I have the same base value and the same argument, then it has to equal 1, because in order to start with myself and end with myself, I'd have to raise it to the first exponent. The next thing is the formal definition for change of base formula. So I've already talked about this, but just to show you the formal definition. So remember, you utilize a change of base formula whenever you have a base that is not 10, because in your calculator you have the log button, which is an understood base of 10. But if you can't utilize that button, so you have like log base 7 or log base 11, whatever, you would use your change of base formula. What I want you to draw your attention to is that you can use this for ln's as well, but we don't tend to really need to use that. Since we are utilizing our calculator, we can just use the regular logs, and that will get the job done. Okay?